Good morning or afternoon, depending on where you are and when you're watching the video here today. So we're in Pre-Cal 30 today. This is Pre-Cal 30 video. We're working on unit circles, what we did last day. So today we're looking at section 4.3 in our textbook, trigonometric ratios, and we're going to be doing this over 2 days. Today I'll do a video on exact values and using the unit circle. So you'll need the unit circle as a reference. So make sure you have your unit circle sheet. If there's one on the computer, let me dig up mine here to show you what we're talking about. So, okay, there's a printout of that on the computer or on the Moodle page above from day 3. Okay, so let's just define what we're doing today. I didn't do any pre-notes for this one, as we're going to do a lot of definitional type stuff and stuff like that. So let's get this set up here. Try to keep it around half an hour today or so. Okay, so today is day 4 of Pre-Cal 30. Okay, so it's probably September 11th if you're keeping pace with me in Vanguard, but it might not be. Today's actually the 9th, but I'm trying to get ahead of you guys. I'm going to try to get a week or 2 ahead. I have another individual that would like to do some courses, but he or she, I can't remember, needs to be a little bit faster, so I'm going to be working ahead a little bit. I didn't do much over the summer. I was intending to. Some of the technology stuff I didn't get set up till August, and then when I tried it didn't work, and then get it going. And so last year's stuff is there, but it's all on Adobe Connect, which is a totally different system than what we're using this year. So I'm remaking everything. Not remaking everything, but most of everything. So that's why it's different this year. Okay, and no one's live with me. So this is Pre-Cal 30, September 11th, day 4. And what we're going to look at today is we're going to get into 4.3, basically the trigonometric ratios. And today we're going to focus on exact values. And then tomorrow we're going to focus on approximate values. So exact values means roots and fractions and radians and degrees and stuff like that being exact. And the approximate one, that's when you use your calculator and you get those decimal numbers and things, that's approximate. So we're going to look at exact values. Now, exact values come from here. These are all exact values, all roots and fractions. Okay, so we're going to mainly use this as a reference, unit circle. Have that handy, laminate it, do whatever. You can always bring it in to anything. And what we're going to do is we're going to look at, first thing I'm going to do is I'm going to look at all the trigonometric ratios. You're familiar with sine, cosine, and tangent. I'm going to introduce, if you haven't been introduced to cosecant, secant, and cotangent. We're going to talk about the 4 quadrants and the cast rule. And we're going to talk about the unit circle and how it relates to all of those ratios. So let's start by looking at basically the unit circle and the 6 types of ratios, trig ratios. I was just doing Pre-Cal 20 about 20 minutes ago, so I'm stuck on the common series and sequence stuff. Okay, so let's look at the primary ratios. And over here we'll do the what they call the reciprocal. Ratios. And we're going to write them in terms of the unit circle. Okay, in terms of the unit circle. So if the unit circle is there, we'll do a little drawing over here, help ourselves out. So we'll do it over here. And then if we, actually, you know what I should do first is the axis first so that I can center it on there. Let me do that. do the coordinate plane and then draw our circle in there. Okay, so that's what we're going to use now for referencing here. And we're going to look at if we have the unit circle, so we have the arrow in there as well. So we'll draw, let's make it a little thinner here. So pop it into a blue color or whatever. Okay, so this is what we're going to look. So if we have, put it in the second quadrant to be a little different. Okay, so there's our angle there. Now, whenever you're doing work with trigonometric ratios, you always have to deal with the reference angle, not this full angle here. The reference angle is always with the x-axis. Okay. Okay, so always at the x-axis. So here we have, we're looking at this angle here. Okay. There's theta. This one here is theta reference. And we've got our x and our y in there. So this is our x, this is our y, and this is our r, which equals 1. Okay, so we got our little triangle there, so we can just make another line there. Okay, x, y, and r. So we know that sine theta is equal to y over r, or y over 1, because r is 1, so it's just y in the unit circle. Okay, so we'll kind of write both so you don't get confused. So that would be equal to y in the unit circle, because r equals 1. Okay, and then the reciprocal of sine is cosecant. Cosecant theta equals 1 over sine theta. Okay, so 1 over sine theta, of course, that would be this reversed. So cosecant theta is equal to r over y. Or if you like, 1 over y in a unit circle. Okay, and this is a unit circle, and this is in general, because it can be any other circle as well. So cosine theta is equal to x over r. And if r is 1 in the unit circle, that's just x. So the reciprocal identity for cosine is secant. Secant is SEC theta. Secant theta is equal to r over x. So in 1 over x in terms of the, 1 over x in terms of the unit circle. Okay, and I'm going to write in my picture there, so I'll move over a little bit. So secant, we know also is 1 over cosine. It's another way to write it. Okay, and then our last one, we'll move this up so it doesn't get into the, our last two is the tan and cotan. So tangent theta, we know that's opposite, oops, forgot the theta. That's opposite over adjacent, that's y over x. And that's equal to, in the unit circle, we don't have, the r doesn't fit in there, so it can't be broken down any. So cotan theta, cotangent theta, that's equal to basically the opposite of that, x, or the reciprocal of that, y. And tan theta sorry, let me keep the same method here. Cotan theta is 1 over tan theta. So those are all 6 trigonometric ratios. These are called the reciprocal ones, secant, cosecant, and cotangent. So you'll notice the relationship. Sine and cosecant, so there's one co in there. Cosine and secant, one co in there. Tangent, cotangent, there's one co in there. Let me move that up so you can see that. Okay, so that's the 6 trigonometric ratios. Okay, so the first type of question, first type of thing you have to be careful of as well, as a little bit of a review, is the 4 quadrants around the unit circle. We're going to look at that on the next page. And then we'll look at some exact values. So if we look at, and the cast rule, I don't know if you know the cast rule, but we'll talk about it. So we're going to look at the quadrants, but I'm going to draw a much bigger one here. So if we look at these, this one is y and r, x and r, y and x. Okay, and these are the same but reversed in terms of reciprocal. Okay, so if we turn the page and we make a great big quadrant here, and this is x and y. X and y. Just trying to get my pen to be the right spot here. It's laggy. All right, there we go. We got it in the right spot. So there's the x and y. So if this is the first quadrant, so x is positive and y is positive. Okay, this is the second quadrant. X is negative, but y is positive. This is the third quadrant. X and y are both negative. Okay, and if you're not sure why, I'll just quickly, y going down, that's negative, y going up, that's positive, y going to the left, or x going to the left, pardon me, that's negative, x going to the right, that's positive. So x is positive here, but y is negative. So if we look at the 6 trigonometric ratios, x and y and r is always positive because it's a hypotenuse. Always positive. So everything in the first quadrant is positive. So everything in the first quadrant is positive. So sine, cosine, and tangent are positive. So we have a little, it's a plus sign. We have a little saying, we call that all positive. All positive. All 3 ratios are positive, and they're reciprocals that go with them. So that means sine that goes with cosecant, so cosecant would be positive. Cosine goes with secant, it's positive. Cotan goes with tan, so it's positive too. Okay, then we will look over here. If we look at sine is y over r. Y is positive and r is always positive, so sine is positive. Cosine is x over r. X is negative, r is positive, so this is negative. Negative over positive. Okay, and then this one over here, the last one, tangent. Tangent is y over x, so y is positive over a negative x, so this is negative. So the only thing that's positive in the third quadrant is sine. So sine, and I'll write the full word so you understand. Sine is all positive, sine positive. Then if we look over here in the third quadrant, sine is y over r. R is always positive, so it's negative y over r. So it's negative. Cosine is negative x over r. That's negative. And tangent is negative x over negative y. Two negatives make a positive. So tangent is positive. So tangent is positive. And then over here, we finish it off by looking at sine. Okay, sine is negative y over r. That's equal to a negative. Cosine is x over r, so that's a positive. And tangent is y over x, so that's a negative. So sine, or cosine, is positive. So we have a little rule here that we can follow to find out whether you have a positive or a negative value for the trig ratio, depending on where the angle is. If it's in this quadrant, this quadrant, this quadrant, or this quadrant. So we call it the cast rule, C-A-S-T, cast. Cosine in the fourth, all in the first, sine in the second, and tangent in the third, along with its reciprocal ratios. Okay, so that's the quadrant cast rule. So then all I need to do with you today then is I'm going to look at two examples of using exact values. So we'll be using this now. So if you look on here, you can even see that we're true. So if I say, okay, well, let's test Mr. Englert. Is sine actually positive in quad 2? So if you look in quad 2, look at 120 degrees. Sine is the second one. It's root 3 over 2. Hey, it's a positive number. Makes sense. Okay? Sine, positive y, positive r. Remember, r is always 1 on these. Okay, so let's do an example of the first type of question. Finding all 6 trig ratios is the first type of question. So I'm going to do that on the next page. Okay, so let's do that on the next page. So examples. So we'll do 2 examples here and then do a little bit of practice. And I'll stop for today. Okay, so all right, let's say the point at L, that's negative 1/3 negative 1/3. Again, I have a fraction. That's a fraction. And positive 2 root 3. I can't write 2 root 3 with this typing. This is why I was going to go into is it root 3 or root 2? Sorry, over 3 is on the unit circle. Okay, it's on the unit circle. Okay, and then the question is, find all 6 trig ratios as exact values. Okay, so we're not going to use the chart this time because this one isn't, it's kind of in between. But all we have to do is use our formulas. Okay, so we know that x equals negative 1/3, y equals 2 root 2 over 3, and r equals 1. Okay, because it's on the unit circle. It says is 1 is on the unit circle. Sorry about that. So all we have to do is we got to go, okay, we'll do sine first. Sine theta. Sine is y over r, or just y, because y, that's 1. So sine is going to be 2 root 2 over 3. There we go. That's pretty easy, right? Okay, over 1, but the 1 doesn't do much. Cosine is also an easy one. That's equal to x over r. R is equal to 1, so it's just negative 1/3. Okay. Got to do tangent. Okay, this is where you have to do a little bit of calculating. This is y over x. So this one we have to write y root 2 over 2 over 3 divided by negative 1/3. Okay, now you know the rules for multiplying fractions. So this is take the reciprocal of this divided one and multiply it. So this would be 2 root 2 over 3 times negative 3 over 1. So that's going to give us, this will cancel out. We're going to get negative root 2 root 2 over 1. Okay, so that's what it is. Okay, now we can figure out our reciprocal ratios based on those. So sine goes with cosecant. So cosecant is going to be the reciprocal of this. So cosecant, actually I'll do it on the bottom so that it's neater. Otherwise I'll be trying to stuff it all in here. Okay, so all right, so sine, we know, we'll just keep it right there. So we'll do cosecant first. That's equal to r over y. So that's 1 over 2 root 2 over 3. So we got to take the reciprocal of that when we flip it over. So you could just flip it over right away if you wanted. 3 over 2 root 2. Okay, is that a good way to leave it? No, because we have to rationalize. So rationalize the denominator. You get 3 root 2. And this would be 2 times 2 over 4. Okay. Root 2 times root 2 is 2, and there's a 2 in front of that, so 2 times 2. Okay, now we go into secant, which goes with cosine, and that's equal to r over x. So in our case, that's just going to be negative 3 over 1, which equals negative 3. And our last one, tangent, cotangent, pardon me, that's equal to x over y, which in our case is negative 1/3 over 2 root 2 over 3. So you know, negative 1/3 times 3 over 2 root 2. Okay, we can cancel out the 3's and we get negative 1 over 2 root 2. So we're going to have to multiply by root 2 again over root 2 to rationalize it. And we get negative root 2 over 4. So there's cos, tan, there's secant, there's cosecant, there's tangent, there's cosine, and there's sine. Okay, so that's the first type of example. And I want to do one more today, and then I'll give you some practice with this. Okay, the other type is to determine the exact value of a particular angle. Okay, and that's where this comes into play. Okay, so let's take a look at that for the generally speaking. So let's go to the next page. And this is our last, what did I call this one? I didn't actually call it anything. I should have. Okay, this was an example of just finding all the trig ratios, okay, given the point on the unit circle. Okay, and then this one, what we're going to do in our last question today is we're going to determine the exact value of each ratio. And then we're going to do a couple of them. We're going to do a negative angle, we're going to do a positive angle, we're going to do a radian, and we're going to do a reciprocal angle. So let's start with tangent pi over 2. Oops, sorry, let me get my marker. There we go. So tangent pi over 2. So we know that tan equals y over x. So we got to go pi over 2 on the unit circle and find out what y and x are. Okay, right here. So pi over 2 is right here. Okay, and we can see that right on that point there, we've got 0 for x and 1 for y. 0 for x and 1 for y. So y equals 1 and x equals 0 from the unit circle. So this is undefined. Okay, can't divide by 0. So there's an actual asymptote there. Okay, let's do sine negative 300 degrees. Okay, so we've got to find what the actual positive angle is. So, well, if we're looking at the unit circle, we've got to get it as a positive angle. So we got to say that this is, if we're going down, we're going to get 360 degrees, subtract the 300. So that is going to be a 60-degree positive angle. Okay, so if you look at the unit circle and you go starting on 0, if you go all the way down clockwise, all the way at 300 degrees, you're going to get to the 60-degree spot. So this is the same as saying sine 60 degrees. Okay, so this is going to be something we just look up. Now, sine is quite easy to look up because if you look at it's just y, because we're using the unit circle. So it's the second point of 60 degrees. So sine of 60 degrees is root 3 over 2. Positive. So that would be the answer for that negative sine value. So we did one with a negative, one with a tangent that we had to divide. Now let's do one that's a cosecant or a secant or a cotan. Okay, so let's do a cosecant 7 pi over 6. Okay, let me draw that a little better. 7 pi over 6. Okay, so cosecant, we know what cosecant is. So cosecant, okay, that one's the one that goes with sine. Okay, so that is r over y. Okay, so basically it's going to be 1 over the y point, or 1 over the sine point, if you like, which equals 1 over y. Well, let's look for 7 pi over 6 in there. 7 pi over 6 is 210 degrees. If we look it up, it's negative root 3 over 2 and negative 1/2. Well, which one's the y point? Well, the y point is the negative 1/2. So negative 1/2. So 1 divided by negative 1/2 is equal to negative 2. And that's our examples for those. Okay, we can draw our pictures if we want, but you don't necessarily need a picture if you look at this handout for yourself. Okay, so I'm going to stop there. We're going to do the second part next day in day 5, but I'm going to give you some practice with the exact value type stuff. The next type of stuff that we're going to do is we're going to be looking at finding angles, given the ratios, and looking at approximate values. But that'll be next day. So let's see if there's any ones that'll be confused. State the exact value for each. Okay, so you can do on page 201, which I'll write this down for you here. Page 201. Okay, anything in number 1. So number 1, you can do any of that. Do one of the columns. So first column, we'll say. Okay, that won't take you too long. Okay, and then it says determine the approximate value. We're not there yet, so we'll skip 2. Okay, until we get there. Okay, and then we'll say turn the page here. Okay, now indicate. They don't have a question on determining the. Yeah, this book sometimes they don't cover everything. So let's see if we can. They don't have one with a unit circle one. So I'm going to give you one with the unit circle one to work on your own, and then we'll do the next parts of this stuff. Unless it's in the word problems. Let me just check here quickly. Oh, there's one. No, that's not it either. Okay. I'll just give you one. So let's say that we have this one here. I'll just type it out. And then try this one, and I'll actually answer this and post it up. If point A is on the unit circle, find all 6 trig ratios. Given its coordinate is, okay, I gotta find one coordinate that works here, so let me just find one that'll work. Oh, here's one. This one will give you nice round numbers. Negative 12 over 13 and positive 5 over 13. Okay. Negative 12 over 13, and for x and y is 5 over 13. So that'll work out to, when you do that, it should give you some nice round numbers. Okay, so I'm going to stop there. You work on, it shouldn't take you that long to do those few examples there. First column, number 1. I didn't even write 1 in there. Ooh. Okay, and then tomorrow will be more of a working day. There'll be a little more work on it, but we'll be looking at finding angles and finding approximate values. So I'll stop here, and we'll do that next day. Where's the stop button on this thing? There it is. See you tomorrow.